Okay, hi, welcome everyone. This is our third session today, and today we're going to continue on with our VQL Fundamentals. Just before we start, let's kick off the server, and we're going to do this the same every day. So the same as how we're doing it is, every day is we're just using the Windows binary with the GUI, Velociraptor GUI. And this is just what we're going to be doing for the rest of the day, working locally on our own system. So it's just going to bring up the UI. And just before we start, there was a quick question here about how to use something that does not match. So we've explained before. So let me just, how am I going to do this? Let me start just as a bit of a segue. I'll start another VQL query. So for example, let's say that we already looked at the globe. We're going to look at globe a lot. Globes equals C users. Just as an example, right? So this is just going to show us all the directories in the users. And then the question was, we know that we can restrict it with a regular expression. So we can say where full path matches, Mike, for example. And then the question is, how do I exclude that? So the opposite of match, and you just do a not, right? So we're not full path matches Mike, right? So that basically will invert the logic of the operation there. But it's not it's not a new operator. It's just an inverse. So it's not full match, not match, right? It's not full path matches Mike. Okay, cool. Well, that's a good question. So let's go back to our exercise. Before we finished yesterday, we were working on this exercise to try and to write a detection essentially from scratch. Try and identify a particular kind of attack or lateral movement that basically uses WMI to create a command shell. Let me just start that again so we can observe it. And you can see that when you run this, WMI process create command.exe, it just creates a process using WMI. And normally that would happen across the network. Let me just go back to our, there it is. Okay, so this was our query. Just put it up at the top. Okay, this is our query. And you can see that we used Pierce list as the plugin. And then from that, we extracted the name, the PID, the parent PID. And then we did a subquery to resolve the name of the parent from its PID, right? So there's the process ID of the parent. And then, we just look it up and print the name of the parent. So that's the parent name. And then we have the command line and so forth. And then we figured out that when we actually launch the command in this way, then the parent of the command is a WMI process server because it makes a WMI call. And so we might say, okay, that is a pretty reasonable detection if we, just look for an executable that matches command.exe and the parent name is WMI, PRVSE, then, that is suspicious, right? Because someone's used WMI to launch this command shell. So this is fine. And so far, we've done this on the endpoint on the server, right? Because we are writing it in the VQL in the notebook. So it's just running locally on our server. But really what we want to do is we want to run it everywhere. We want to hunt for that. So in order to do that, we need to write an artifact. So an artifact is a way of us essentially encapsulating this query inside something that can be reusable. So like a YAML file that can be reusable. So let me show you what the artifact, and I think we actually rushed through that part in the first session. We kind of skipped it. So I'm going to do it now. I'm going to introduce artifacts. I just mentioned it last time, but this is the artifact view, the view artifacts screen, right? And this screen is basically everything to do with managing the artifact repository on the endpoint, on the server. So each Velociraptor server comes with a bunch of artifacts, as you can see here, and you can search for them as well. So for example, let's say anything to do with processes, right? We've got a whole bunch of different ones. You know, this one, for example, process memory. We're going to scan process memory with the Yara rule, right? So we're going to scan it, and then, you know, if it hits, we're going to grab process memory. So that's a pretty common use case. Or, you know, this one looks for PS exec and actually kills it if it detects PS exec running. You know, this one is looking for process creation logs, or process execution logs, and so forth, right? So each of these is an artifact. And if you click on those, then you'll see that they have a bit of a description here. And then there's a thing called the source, which is the source code of the artifact, which the VQL essentially. And then we can see this is the VQL, right? So this is, you know, and we're going to learn about how exactly to write these things, but, you know, just so that you can see what it is, right? So here, for example, is a subquery, right, that we talked about. Now in here, we are actually looking at the artifacts that Velociraptor comes with it. So it comes with a whole bunch of built-in artifacts. So currently this is about 250, something like that, 250 artifacts that it's built in with, and, you know, and you can load more artifacts. But the artifacts themselves are just YAML files. So there's nothing really that special about them. And you can actually see the YAML file if you just select any of these artifacts. Then you click the little pencil, I guess, over here, and it will bring up an editor to show you the artifacts and allow you to go ahead and actually customize it. So you can customize these artifacts by just modifying it's just a YAML file. And you can see over here, the name of it, there is a name. Each artifact has a name. And when you update it through the UI, you know, we try to make sure that you don't override or kind of, you know, destroy like built-in artifacts. So it always adds a name custom to the artifact. And in fact, if I didn't have that, so it adds it for you, but if you remove it, then it will refuse to save it, right? And we can click save. Then it will say, you know, you have to have the word custom in the artifact, right? So, so this is just a way of making sure that, you know, we don't override the artifact. But really, internally, there's no real difference between custom artifacts and built-in artifacts. They're the same thing. They can do the same thing and work the same way. So that's really all it is. Let's have a look at, if I'm going to write a new artifact, so from scratch, I could press the plus button here, and that creates a new artifact. So it starts off with a bit of a template to sort of make it a little bit easier for us to fill in the blanks kind of thing. And these are not all the things that you can write in an artifact. They're just the most common things. So most of the time, that's what you'll need. And, you know, the rest of the course, we're going to be doing a lot of these things. We're going to write a lot of artifacts. So the first thing that you got to write about an artifact is the name. So that's the name of the artifact. And that is how you choose it and select it and search for it, you know, that sort of thing. You can also put in a description, which is a human, you know, readable description. This is where you can put, you know, some keywords to search for it. So when you search for the artifact in all the search screens, then it searches, you know, like here, it searches the name and the description. So that just makes it more discoverable. So you can find out, I can find it a little bit easier. Then we have the type of the artifact. And these are the different, this is basically just controls the way the UI presents those artifacts and where these artifacts make sense to run. It's just a recommendation because the VQL, it doesn't really have any like limitations on the VQLs. The query itself is the same, but it's just where it's going to run. So it gives you like a hint for the user about where they're supposed to run it. So if I'm going to write an artifact that is designed to run on the endpoint to collect information from the endpoint, then it would be a client artifact. A server artifact is actually running on the server. So this one is usually used for administration or to do some post-processing or something like that. A client event artifact, we're going to talk about that later today. And that is a monitoring type artifact that can monitor the endpoint. And then we have a server event, which is the same thing, monitoring the server. We'll talk about that as well. Then artifacts have parameters, which we didn't really talk about that in the first session. So we can go back to talk about it. But the idea here is that you can tweak the query a little bit. So instead of having, so it's kind of like you can make a VQL query that's very flexible, that's a little bit more flexible than just hard-coded, and then users can just tweak it, give it some parameters and control the way that it runs. So it makes it a little bit easier to to tailor the artifact to the case. And then we have this thing called the sources. So again, that's where the VQL source goes. There is a thing called a precondition. A precondition is basically a query. It's another VQL query that will run. And if the query doesn't return any rows, so it's we consider that it's false. And so in that case, we just skip the query. We just don't run it, right? But if the precondition returns any rows, so it's true, then we execute the query. So the reason for that is that you can write an artifact and then you can safely run that artifact everywhere. And if it's not supposed to run, then nothing will happen, right? So it's kind of it's a safety mechanism. So like if I'm writing an artifact for Windows and I accidentally launched it against Linux or Darwin, then nothing will happen, right? It will just I'm just going to leave it like if I make the precondition like that, then it's not going to match. It returns false, and I mean it will still evaluate the query, but it's actually going to take no time at all to just not do anything, right? So it's just a safety mechanism. So that's the precondition, and then over here we put the query. So that vertical bar here, the pipe character, that's a YAML thing. And it's a YAML way of just kind of like keeping the indents correct and stuff like that. So we pretty much always have that there. Yeah. So there's a question. Type does not influence the VQL at all. So is it just informational, similar to a field in the meta section of the YARA role? Yes, sort of. So it doesn't really affect the way the type here doesn't affect the way the VQL runs, but what it does do is it affects the way you can search for it. So if I say, for example, had a type of client, that means that when I go over here, and I find my client, and then I click collected and I click plus here, that's where I'm going to find it, right? It's just searching for those ones. So for example, I'm not going to be able to see server artifacts because it doesn't make sense to run those on the client, right? So it's informational, but it's more a UI thing as well, right? But of course, using the API, you can do whatever you want. So you can launch a server one on the client or a client one on the server. You can do whatever you want, right? But it's just for the UI to just make things a little bit less confusing. As you can imagine, if over here I had server artifacts and people would accidentally run it and it won't work, right? It basically doesn't make sense to run like a server artifact on the endpoint. Yeah. So, okay. So cool. So that's an artifact. So what we're going to do now for this next exercise is we've got a query over here. That's our query. And we want to convert that into an artifact. Can you create a new types? There's a question, can you create a new type? So a new type of artifact? No, because the artifact, the type is just, what the UI is going to do with it, right? So it's just, so it doesn't, you wouldn't really need to create a new type. It's just for the UI. Okay, so yeah, so let's look at how do we encode this query in an artifact. So what we would do is we'd first go over here to the artifact, view artifact screen, right? And then we would create a new artifact, just like I showed you. So here we have the template. So the first thing we're going to do is we're going to give it a name. So this one is going to be, Windows dot, let's call it WMI dot parent process, like that. I don't know, something like that, right? And then I give it a description, detect processes launched from WMI, right? Like something like that, right? So now I can find it and search for it. So there's a question, when you say the server, do you mean Velociraptor server? Yeah, I mean there's Velociraptor server, not server on the network, because yeah, if you have a server on the network, it's still a client to Velociraptor, but yeah, when I say the server, I mean Velociraptor server. Cool. Yeah. So if you take it out completely, the default is client, right? So that's the default if it's empty. So you can just remove that. And we want it to be on client because we are going to collect it from clients. So that's what we want to do, right? I'm going to leave this. I'm just going to skip this one for a minute and go over here. I want it to run on Windows. And so I just do that. That's great. So that does that. And then you see I have, my hello world query over here. So, I'm just going to remove that because this is just like a placeholder, right? Then I'm going to go over to this tab over here. I'm going to copy this query. So I'm just going to go copy and over here, paste. And then because it's a YAML thing, it has to kind of be indented over. So I'm going to highlight it and press tab twice, and then it becomes, yellow. So that means that, it's kind of indented correctly. So there's my query, and that looks about right? So I'm pretty happy with that. But what I would do now is think about how would someone use this, right? Like when I'm in my example, I'm looking for cmd.exe, right? But maybe the attacker is going to run PowerShell, or maybe they're going to run another program. And I want my users to be able to tweak that a little bit, right? So it's not hard coded. So in that case, what I actually want is I don't want to hard code this, cmd.exe. I want to have some flexibility in this artifact. And this is the point where I actually can think about adding parameters. So let me just so I'm going to add a parameter to control this. So the first thing I'm going to do is I'm going to say, well, it's going to be, give it a name. So the name is going to be process regex, right? Because it's just the regular expression for a process. I have another question. Does the query need to start with a pipe? Yep. So I mentioned that before. And the pipe here, the pipe character here is a YAML thing, right? It's the YAML format uses that to denote, a block of text with line feeds, a multi-line block of text. It's unfortunate because YAML kind of is not the easiest format to use. This is, I would have, if I had to do it, I would have chosen that format to be the default, because that's probably what you always want. If you don't have that pipe, it still works, but it just messes up your indentation of, when you look at it. So yeah, it's recommended to almost always to use that pipe character there. Yeah, it's just a YAML thing. So so here we have a name of the parameter, and all parameters have a default, so we can give them a default, right? And we're just going to do cmd.exe, so that will be the default, right? So when someone doesn't want to tweak it or doesn't want to do anything with it, they just hit the button. It should have, in most cases, you should try and make it relatively sensible, like the defaults. And then over here, we're just going to call it process regex, right? So what happens is, the way that this works is that when I'm launching the artifact on the endpoint, Velociraptor will ask the user to fill in these parameters, and then it will send these parameters, and it's actually going to send them in the environment, right? So when the query starts running, those parameters become part of the scope, as we explained before, and so you can just refer to them by name, and then they'll just be available, right? So that's how it works, and that's really all it is. You press save, and it saves it. Now, if there was a syntax error or if there was some problem with the query, then it will tell you about it. So let me just show you a syntax error. Like, so let's say that I forgot this, from, for example, like I just made a mistake, and it will tell you, oops, that the VQL is not right. So it will stop you from messing it up. I mean, it's not foolproof. Like, if you can still write VQL that doesn't make sense, but if you have a simple typo, and especially with YAML, you have you could do like this kind of thing, and that breaks the YAML, so it's wrong, and it tells you line 15 it's broken, and the line numbers are not always the best. So yeah, so that's the that's how we create it. All right, so now here's our parent process. That's great. Now we're going to launch it as an artifact. So we're going to go over here, collected, and let me just close our guy and do it again. Yep. So now I have something to hunt for. That's great. And I'm going to press plus. Okay, and so I can actually either search for it. I can look it up by WMI. And as I mentioned, it's the description that's searched for. So if you put keywords in the description, it's easier to find stuff. And then, I select this. So this is like a highlight, unhighlight. If you unhighlight it, it unselects it. So make sure it's highlighted, so it's selected. And then you basically work your way down here in order. It's like a wizard, right? So you go like from left to right. And then the next thing, configure parameters. So you can look at that. And over here, so you can actually select a number of different artifacts here. I can select a whole bunch, right? But in this case, usually I just do one, but you can do a lot at the same time. And then when I can open it, I can actually also cancel by deleting this, but I can open it, and that allows me to tweak the parameters. And as I said, it's usual that you can have like normal, you can use the dot as well as the wildcard, like as a regular expression of dot, just matches anything. So you can just use a dot as well. That works. So when we do this, we just click. I'll talk about resources later, but we can just click launch, and it just comes back straight away with our results. So because this one's a very quick one. Oop. Yeah, so you can see that obviously system is not great because everybody's a parent of system. Okay, that wasn't. Yeah, so you can refine the artifact and so on, right? But we found our little command prompt here. So this is the one, the cmd .exe, right? So okay, cool. Now, so that's how we create an artifact, right? And then we can hunt for it and everything like that. Now, it might seem that someone asked me that the other day, is how do I create a Windows artifact on Linux? Because it's how do I actually write the VQL? And that's why I'm showing you guys that you can run Velociraptor GUI on Windows, because you need to actually be able to do it on Windows, right? Otherwise, it just takes too long to figure out how to write the artifact. Yeah, could you slow down and show how to load the artifact again? Yep. So once we write it, yeah. So let's do that again. So we write it from the editor, right? So it's this one. And all you have to do is, so now that I've written it, I can edit it as well and modify it and look around and stuff like this. And then once I'm happy with it, I just save it, and it will just then appear in the search window, right? So then I can search for it. And then to collect that artifact, it's the same thing as collecting all the other artifacts. You select your client, you point at your client, you click the collected artifacts, or you can go to this screen here. And then you just add a new collection like this. Then you just select it. You know, there it is. That's my custom one. And that highlights it. And when I select it, it basically just tells me. So it's the same thing that we wrote in the YAML file. This is where you put in an explanation for the analyst to find this artifact easier. And then I just go to the next step along the way, the configure parameters. And then here, I have all the parameters that I'm going to configure. But by default, they are folded, right? So they are kind of hidden. So I have to click on them, either click the name here or the little, spanner to configure the parameters. And depending on the parameters that I specified in the YAML file, I can have different parameters here. And we'll see later on that you can have different types as well, and you can have like timestamps and dates and things like that. But here is where I can tweak it. But by default, you shouldn't need to. I mean, you should do it so that it's easy to use, right? And then all I do is I click launch, and off I go, right? And that's all it is, right? Once I launch it against the endpoint, off it goes, right? And then hunting is the same thing, right? It's the same thing. We've talked about that the other day. You set up your hunt, and then you select your artifact in the same way. And then, I mean, here you don't have to put a description in, but you can put one in. And you select your artifact in the same way. So this is the new artifact that we've created, the customized one. And then configure the parameters. Same thing, exactly, right? And then once we're doing that, we click launch, and we're building a hunt, right? So now it starts off in the posed state. So we click start, and off we go. And it will schedule it instantly and run it. I mean, we only have one client now, so it's not that great, but it's the same thing, right? So there's just the one client. But this is how you hunt for it. So, if I wanted to do this hunt, say, everywhere on my network, is there any kind of WMI spawned executables, then that's a detection, right? It's not the best detection in the world, but it's just an exercise to prove the point, right? So we went through the full process in this exercise, right? We went through, played around. Usually you have to find like a, proof of concept or some kind of exploit or something like that you can use. If you have something running, where do you stop it? Stop the collection, are you saying? Or yeah. So if you have a collection, well, we can talk about it now. Some of the queries may take a very long time. We're going to talk about MFT a bit later on, but just to give you an example, this particular one collects the whole MFT. It's going to be pretty huge, right? So if I launch it, then you'll see that it's going to go off and collect, and you'll see a lot of rows coming back, and it might take a few minutes to do that, or maybe longer. You see, and at that point, you might say, "Oh no, I don't want that." You can cancel a query at any time. If you press that stop button, then it actively goes out to the client and cancels that straight away. So so it stops, and you'll see the collection become like an exclamation point, and it will say canceled, right? So this is a way of if you have a query accidentally that takes too long or takes much longer than you think you should, you can cancel it immediately, right? So yeah. Same thing with the hunt. If you have a hunt and you accidentally launch the hunt and suddenly, all your endpoints are starting to do a lot of work and you're like, no, I didn't want that. You can cancel it and we'll actually go out to the endpoints and stop the hunt. So it's not, so it's a little bit of safety there. Another question, is it possible to execute VQL for a client in the notebook? I've noticed it only returns for the host or the artifact already collected. So when you're running something in the notebook, then it's running on the server, right? So whatever the server can do, you can do it. I mean, you can run any VQL on the server and you can, check for, the MFT on the server or whatever. You mean hunting. So you can use the notebook to set up hunts. So the notebook runs anything here. And I can show you, for instance, there we go. Oh, make another VQL cell. So you can evaluate. So there's a whole bunch of plugins that are designed to work on the server, that work on the server, and one of them is hunt. Sorry, it's a function, right? So hunt. Now hunt is a function, and as you can see, it says launch artifact collection. Oh, well, actually, it launches the hunt. So you can set up a hunt in here, right? So you just give it the artifacts. This will be like your generic client info, for example, and then you can set up the expiry and blah blah blah, all this kind of stuff. And then spec is how you can pass parameters to it if you needed to. In this case, we don't really need to. And because it's a function, we don't really need to select from anything, so we can just select it from scope. And then when we do that, then it creates a description. Sorry, we need to do a description. Description equals a auto hunt. An auto hunt. So it's automatic hunt. And you can see that when you run it, it creates the hunt ID and it goes. It's created a hunt, right? So you can actually go over to here and you'll see the hunt, right? It created it. So you can create it from the notebook automatically. When you do it that way, when you do it from the notebook, it doesn't really create it in a post state. You see, you would have seen that when we created in the UI, it creates it in the post state and it makes you press start and it has a dialog box, makes you think about what you're doing, right? So we don't want you to, suddenly, cause damage to the network. When you're doing things from VQL, there is no safety, right? Because we assume you know what you're doing, right? So you're just going to launch that hunt. It just goes, right? So so just be aware of that. So can we search against endpoint in our environment on the fly using the notebook instead of the host server? So that's a good question. You can schedule collections and you can schedule hunts so you can schedule a collection against a specific endpoint, or you can schedule a hunt across all the endpoints from the server, from the notebook. Anything that you can do in the UI, you can do in the notebook. It's just an automated way of doing the same thing, So I'll show you how to do that in module 7 when we're doing more of the administrative type things. But by the way, there is actually a new feature over here. We talked about the shell last time. Remember, I showed you how we can run like PowerShell. There is also a VQL here. So since recently, I think maybe like 2 or 3 versions ago, you can actually run VQL from there. It's not really recommended. Let me show you how. So if we can select the VQL that we did before, so this one, it's not really recommended. So, but you can just run ad hoc, VQL, so you can make that one bigger a little bit. You can do that now. It's not super recommended. Usually you'd like to create a artifact and then launch it and then collect it. And this way it's more ad hoc, right? So it's a little bit like we didn't create an artifact, we're just running any kind of query. I mean, it still works, but it's a little, I don't know if I like it, but people wanted it, so so it's in here like that. Yeah, you'll see that what it does is it can actually launches an artifact that runs any like arbitrary VQL basically on the endpoint, and then it sends the query to it. So yeah, so it's like it saves you a bit of a step. I don't really like it because I like to use the artifact to be able to reuse it so other people can run the same thing again. Can you get something similar for a Yara rule? Yeah, so for a Yara rule, you don't have to do anything special, right? Like the file finder, there it is, Windows search file finder. That's actually how it works, right? You just paste your Yara rule in here. So you just paste your Yara rule in here, and then you find out what you're searching. And you can also limit it by dates and times and stuff like this. And then you can upload the file if you want. So, like here, you can go like rule X, strings. Yeah, we're gonna do exercises like that. Actually, we'll do an exercise like that a bit later. But yeah, you just type the thing in and off you go, right? So it's just you can also just, if you have a hit, you can just grab the file or just grab the hash or whatever you want. But yeah, so it is kind of ad hoc. That's how it works for Yara. So yeah. All right. Let me just go back on track. Okay, so we've done this exercise. And yeah, so the point of this exercise was to show you the full cycle. And we're going to do that a number of times. So it's not just the first time, but this is kind of the process, right? Develop the VQL on the machine, on the target machine that you're trying to work on. So if you're working on a Windows machine, you should run it on Windows, and also try and find the POC that you can actually detect, right? So so you can test it properly. And then once you test it and you come up with a query that you're happy with, and then you can copy that. And usually, and the reason that we're copying it is that we're working on Windows to do this in the notebook, right? Just like we did here. And then ideally our server is going to be on Linux. So we would have to essentially like open another tab and then go to our server. This would be our actual server. We go onto this screen here and then create the artifact there, right? So yeah, it's not the yeah, so that's the easiest way to do it. Okay, so we have another exercise. So that was an easy exercise. Let's do a bit of a more interesting exercise, and just to show you again how now we're going to apply our VQL skills to build a more interesting or more complicated artifact. Hold on, there is a few questions. Before we start, let me just answer these questions. Can you create conditional VQL if specific parameters are selected? Very good question. Yes. So the parameters in the VQL, you can use them inside the query. So you can do things like if or conditions. We'll talk about that. So you can have an artifact that does different things. In fact, this is exactly, I've just shown you that right here with the file finder. Windows file finder. That's exactly what it does, right? So we have buttons here that says, do you want to upload the file? So then it does one thing based on that. Or if you want to calculate the hash, so it does something based on that. So you can basically control the way the artifact works using these parameters. Another question, if artifact collection is halfway through and the client goes offline, will the artifacts be collected once the client comes back online, or it won't? That's also an excellent question. So the way it works is that the client on the endpoint, it runs the query, right? Now, if the client is rebooted, so like it turns off, right? Well, then the process is the Velociraptor process. It stops. Well, we're out of luck, right? We basically terminate. The query stopped. But if the client goes offline, so for example, like let's say it goes to sleep, someone closes their laptop, and then they go to sleep, and then they open their laptop, maybe offline or something like this. Then the query continues to run, and then the results are actually buffered on the endpoint in a buffer file. And then when the client comes back online, it syncs that buffer file to the server. So to some extent, the results can come in even when it's offline, and then it will sync it later. It's buffered on the endpoint. But if the process is terminated, then we don't actually restart it. Like essentially the query is lost. You have to reissue it again. Another question: can you use VQL to remove duplicate results or do things like unique and sort? Yeah, we're going to look at that. Yeah, absolutely. So unique and sort and all this sort of stuff, that's simply group by, and we're going to talk about group by later on. So yeah, that's today. Okay, cool. So let me just continue on with this next example. Great. So so this example is a typical enrichment example. And so what we want to do here, and this is really where the power of VQL is, because VQL is like a glue. We have all of these capabilities in the tool, and then VQL is allowing you to glue those together and create a new kind of capability and enrich the data, get more data, and that sort of stuff. So this is a typical use case to enrich NetStat. So what we want to do here is we want to get extra information about listening processes. All right, so we're looking for listening processes, and then for all the listening processes, we want to get the following information: the executable that's running, that's running that process, the user who launched it, the process, all the DLLs that are linked on that process, possibly a manufacturer, like, is it made by Microsoft or something like that, and maybe a compile time, or, so this is like a PE type header type stuff, right? So the idea here in this exercise is that we're getting information from lots of different, places, lots of related things about the same, the same thing, right? So we're just putting them together. It's your typical enrichment type artifact. So let me just jump straight into it. So I'm going to make a new cell like this, and okay. And then I usually like to just make it like this, a bit bigger. All right. So the first thing I'm going to need is the NetStat plugin, right? So that tells me about listening processes. So I usually do select star from as the first thing, just because I don't know what columns it's giving me. So and then I look at my completion, information, and it says NetStat. Okay, collect network information. That sounds about right. Okay, and then I press question mark. What does it require? So it doesn't really take any parameters, right? These are just different functions, and so there's no arguments. So okay, so if it doesn't take parameters, what sort of information does it give me? So usually I can just run it like this, but usually I like to limit it because there's a lot of rows, and I don't want it to take too long. So I'm just going to take 50 rows for now. And this is what the NetStat plugin is giving me, right? So it's giving me a whole bunch of rows. Remember, plugins just return rows, and each of rows has different columns. So if I press the little binoculars here, that shows me the row data, and sometimes that's a lot easier to see what you're getting, right? And so you can see that each of those things here, you can fold them. That's a row, right? And then we have multiple of them. So okay, so this is the information we get. So we get the family which is the, the socket family, the type, so 1, 2, 3. So these are just so this is basically coming back from the API. So you can look up the API and say, what does that mean? There's a listening address, which gives me the IP address, and the port. And so, sorry, that's the local address, that's the remote address. So if the socket is connected, that remote address would have an IP address. You can see for some of them are established. If it's established, I actually have a local address connected to a remote address. So I have two ends, right? But if it's listening, then usually I only have a local address. The remote address is 0, right? Because it's listening, right? So that makes sense. So over here, I've got the status is listening. And then I have a PID that tells me the process that's listening. So that's a PID. Then I have a timestamp, so I know when it started listening. So that's the timestamp when the socket was created. And then I have, whether it's an IP. So this string is sort of the same as this family, right? So so it's just a string way of it. So okay, so let's have a look. So in this one, we are supposed to really be looking at listening. So we don't care about the established IP addresses with info. It's not possible. So the IP address, are you saying the IP address of the endpoint or the IP address? So this is the IP address of the remote address, right? So if it's talking, see if here it's established. So it's the IP address of the other end of the system, right? Okay, so in this case, we want to get the listening one. So first, straight away, I can just go where, and then status. So that's the status, and I use my regular expression match, listen, right? Okay, so off we go. Oops. So that's just going to filter out just the listening addresses. Now, if I'm just looking at listening addresses, then the remote address is always 0, right, by definition. So I don't care about it. I only care about the local address. You can see that the local address is like it's like a dictionary. It has a local interface, the IP, and it has a port. So the next thing that I always do is just remove the columns that I don't care about, because I just want to tidy it up a little bit so it's not so cluttered. So over here from these columns, the only thing I care about is local address, so local address. And then I'm going to care about, so the status is, they're all going to be the same because I'm filtering on it, so obviously. And then PID, I care about that. I'm going to need that. And maybe the timestamp will be kind of cool to have. And then the other stuff is really not so important, right? So I don't care about it. So the next step, I'm just going to just clean it up a bit, okay? There's a question. Oh yeah, so, okay, yeah, no worries. People are talking about sysmon. We're going to talk about sysmon a bit later as well. Okay, so that's the first step. Now I'm going to go back to my question, and I'm going to need to know a binary path on disk. So the binary path is like the thing that's running. It's the process that's running. So I need to find out the process that's running, but the only thing that I actually have is the process ID. I don't have anything else about it. So, but that's okay, because I actually know how to do that. Let me do a subquery to find out stuff about this process. Right, so select stuff from, and we've seen this before, right? We know that the PS list plugin tells us stuff about processes. Great. So question mark, you can see it takes a PID. Awesome. And then, we're just going to pass the PID to it. And let's just see all the stuff that it gives me. But let's just reduce the number of rows, because, I'm not going to need most of this information. So that subquery is going to basically give me the row, right? So this is the information that we've got, the PID, the PPID, and the name, and all this sort of stuff. So it depends on what information I actually want about this process. But I need the binary path, right? So the binary path is the executable, like that's where it is, right? So from here, I'm going to really just need the executable here, right? I can get other stuff just because why not, right? And I want to know the username that launched the binary as well. So that's the second thing, right? And that I'm looking for. So that's this username here. So username. So essentially what I'm doing now is just in the subquery, I'm just getting those fields that I care about, right? I don't care about the other things. I can get the seed if I wanted. Maybe the command line is useful. I don't know. So you basically just kind of choose what you want from here. Command line, something like that, right? And this is the creation time of the process. So this is the time of the socket. This is the time of the process. Okay, cool. Yeah. Okay, so let's have a look. Great. So now we can see that we've got some information here. Okay, excellent. What else do we need to know? Okay, we need to know the linked DLLs, right? So all the DLLs that are linked to this process. Well, how do we do that? Well, it turns out that there is actually a so let me just, before I do that, I'm just going to rename that column because it's a little bit harder to see. So it's going to be process info. Just going to call it that. And then I'm going to do another subquery to look for the linked DLLs, right? Select star from, now modules, enumerate loaded DLLs, right? So it just shows me all the modules. So it's sort of similar to the volatility plugin of the same name. So what parameters does it take? It takes a PID. Excellent. So I'm going to provide the PID. And we're just going to do 5 for now, just a little bit, because it's going to return a lot of DLLs. You see, there's tons and tons of DLLs. So what it's doing here is it's actually going to run this subquery here, and essentially all the rows come back as an array because it's a subquery. And then you can see that we only really care about, so we actually get information about where the DLLs are mapped and stuff like this, but we don't care about it. Really, all we care about is the executable path. We don't care about the rest. So we can just change that star to exe path like this. Okay, and so that just makes it a little bit easier. So you can see, okay, this is the list of all the DLLs, right? So let's say as linked DLLs, right? So that's this one. And what else do we need? Manufacturer, if available. Okay, so that's cool. So now we need to know information about the manufacturer of the binary. So the binary is on disk, okay? And there's metadata in this binary on disk about the manufacturer, like, from the PE header of the binary. So let's try and parse the PE header and see what information we can get, from the PE header. So this is the executable. So all we do is we do another subquery. We're going to just like, but for this one, we just need to parse the PE header, which is actually a function. So it's not a plugin. It's just a function because we just give it. So remember that a function is something that just takes a value and returns another value. And a plugin is something that returns lots and lots of rows, or one or more rows. But in this case, when you're parsing a PE file, it just tells you all the information about the PE file. So it's a function. So it takes these parameters, accessor and file. We'll talk about accessor tomorrow, so just ignore that for now. But the file name is going to be exe, right? So it's the executable. That's the file name. And so let's see what it looks like a little bit. There is a question, just a moment. Question, as powerful as they are, why do we continue to add nested subqueries, even though we can get that filtering data from the where clause? So you can't really get data from the where clause. The where clause is only for, it basically just returns true or false. So you don't have to do sub filtering, right? Like essentially, in this case, there are subqueries. You can use these nested, the stored queries that we mentioned, the other day with the let, like this. But I just wanted to show you how you build the query up. Could you use subqueries here? I mean, you could, right? You can, and I'll show you that later. Oh, I can show you that now, I guess. Oops. So we can go let. So let's say we want to do this guy, modules. Get modules. So this is kind of like a stored query, right? So then here you can just do get modules. So it's you can do it like that, and it may be a little bit easier, but it still does the same thing, right? But yeah, I don't know. Yeah, I mean, when you have a lot of these nested queries, this kind of thing is a little bit more readable. So yeah, so it would be good, yeah, to do that. But it's more complicated. I didn't want to introduce yet another concept of this. So we'll start off with these nested queries, and then we can refactor it to this kind of thing. Is there a way we can delete history on shell commands? So delete history on shell commands. There shouldn't be any. You mean on PowerShell? I don't know. I mean, you can I guess do anything. I guess you can run arbitrary PowerShell, but we don't do anything out of the ordinary to delete anything. If that's the question. So we just, if you're running shell commands using the shell feature, then it just runs PowerShell with, we just shell out to PowerShell. So if it stores history, then that history will end up, being stored there. Okay, cool. So yeah, so you can do stuff like this for the modules. I mean, it still works, but okay. I didn't want to confuse it too much. Let's look at our process info now. So the process info is this subquery here, and we just added the parse PE. And we're parsing these PE files. So the parse PE function, all it does is it takes a path to a PE file, and then it parses stuff out of it, right? So it tells us information like about the file header, and this is the time date stamp, but it's not really a date stamp anymore. It's not used. It was at one point used as a date stamp, but it's not a date stamp now. And then there is this GUID, and the GUID is actually pretty good because it tells you a little bit, about if they left debugging symbols in there, like PDB file, then that GUID will be a fairly unique identifier. So sometimes, malware accidentally does that. And then we've got the sections. So these are the different PE sections, not so interesting. But the most interesting thing is this version information that comes out of the PE header. So this is like a resource section, and some manufacturers, not everyone, but most manufacturers actually fill this information in. It's not really the same as like a signed thing, but it's not really signed, but it's there. So, it can be used sometimes to identify Microsoft binaries. So in this particular question, and that's the imp hash here. And then we've got the import table over here, right? And then the export table over here, if there is one. If there is a DLL, it will have an export table. But the import table is useful to be able to more or less fingerprint the binary, and then the imp hash is useful as well. So this is useful for example to try and find binaries that were renamed. You know, for example, if attackers are using lol beans, living on the land binaries, and then they might rename them. So they're still signed and they'll still work, but, you know, a lot of the detections are, you know, very simplistic and rely on file names, and it will fail for that if you have very simple detection. So you know, you can use these kind of things to try and identify the binary. But in this example, all we care about is this version information here. So let's get that. So over here, we're just going to do the dot version information. And this is coming back to the question, remember, that we had yesterday, where if you've got, you know, a bit of a structure like a, you know, a dictionary in here, how do you get, so this is the function call, how do you get one of the fields, just the dot operator, right? So yeah, so if we do that, then we end up with just this information here, company name, file descriptor, these kind of things. So we can rename that to make it a little bit, you know, easier. Yep, a little bit easier to see. And there we go, right? So we've got a bunch of information here. Got an exe, version information, username, command line, all this sort of stuff. So this is pretty good. You know, yeah, this is pretty good. And I think that's basically all the things that we are in the compile time, I guess. This is all the things we wanted to do in this exercise. Is there a module to check whether a PE file is signed and the signature is valid? Yeah, of course. So you can do that. I mean, we can extend it, of course. There is a authenticode function called authenticode. Authenticode is the signing mechanism in Windows, and it's just a function. You give it the file name, and it tells you information about the file, you know, from, you know, whether it's authenticode signed or not. So I'll just show you that real quick. I mean, it's, oh, sorry, I have to put another comma here. Yeah. So it's just calling the API. It's not really that much of a rocket science. It's just calling the authenticode API, which is also cool because it still tells us information about publisher link and more info. So this information is coming from the authenticode part of the PE header. And then finally, if it's trusted, right? So this is the API. So the API itself is going to compare the certificates and the signing and all this sort of stuff. It's good, but be aware that if the attacker added like their self-signed certificate to the root store, then it might not, it might show that it's trusted, but, you know, it's not, right? So so it's not foolproof, right? Because it's done on the endpoint still. How can we do? We asked that one already. Yeah, cool. All right, so cool. So yeah, so this is the netstat. So again, we're walking through the process. We're just building it up, adding. We can format. You can format using this way. You can format things in a little bit more better way. So, for example, in here, this is kind of funny. It would be nicer to actually format it, you know, a little bit better. Format using the format function, which takes a format string %v. %v is like the it's like in Python's %r, I think, %s. It's just a string expansion, and then question mark args. So it takes these arguments in a list like this. L address dot IP, comma, L address dot port, like this. So this is just a better way of formatting it sort of like this, right? So it's a little bit cleaner. Is PE info a shortcut for paths PE? No, PE info. Let me see. You mean the plugin PE info? PE info. Or select star from PE. No, there's an artifact called PE info, but that's a little bit different. You use PE info there instead of pass from the slides. Ah, really? PE info. Oh, okay, no. So it's the name, right? That's the name that we use, right? So what's happening here is that we called parse PE, that's the function, right? And then as we rename it to a PE info. And then because PE info now is like a dict, right? Then we can go and grab each field. So the reason that we're doing it is because we don't want to calculate it twice. So we want to calculate it one time, and then we're basically referring to different members of that dict. So yeah, so it's not a function; it's just a variable name that we're calling it, or column name, I guess. Yeah. All right, but a good question. Very well observed. Cool. All right. So yeah, so you can sort of tweak it. You can see that you can build it up, tweak it, control the the different fields and so on. So which is that's kind of the point. Once you are happy with it, then again we're just going to create another artifact. You just copy it all into an artifact, and you can remove that limit and call the thing. So now it's going to take a lot longer because it's going to look at all the different listening sockets. And then you'll also see that there are some log messages. So you'll see these are the log messages that happen when you run the query. For example, it can't open the DOS header. So what's happening here is that at some processes, because we're looking at the executable from the PS list, and some of the processes like system, they don't have any executable defined, right? So there's no executable there. So we're trying to open it and it doesn't exist. So there's a few like errors here. These errors mean that the handle is invalid. That means that we can't open a handle to that process. So something like system PID4, PID4 is the system process. You can't really open it. And so for certain things like the modules plugin, so modules, we need to enumerate the DLLs, right? In order to do that, we have to open the handle to the process. And so some of them we can't. So LSAS, is protected. So there's a whole bunch of processes that we can't really do that. So we'll get these kind of errors in here. That's perfectly okay. That's fine. But you see, we've got the stats here. This is how long it took, what we did with it, and then we've got the data. So we've got a ton of data. This big list of data here is probably, I don't know how useful it is, but it really only took 2 seconds to run the thing, right? So it's pretty quick. And then we've got all the additional information in here. So did we create an artifact? Yeah, so we could just create an artifact from that. I think we're fine. We'll just skip that. We understand how to do that. Just go through that, creating the parameters and so on. Now, just going back to the artifacts. So with the parameters, you can create as many parameters as you want. Let me go to our artifacts that we customized before. So if you remember, we built our, this one, parent WMI processes. So you can add any number of parameters that you want. And let me just show you, you don't even have to use them, right? So we're just going to add a couple of interesting ones. So a lot of times you want to have like a before and after date, something like that. And you can specify a type timestamp, right? So that is the type of this parameter. So when I do this, when I now go and try and collect it, okay, I'm going to hit search, grab my artifact from here, right? So this is the one that we did. And because we added the new parameter, it shows up here. So now if I look at the, come on. What happened? Do that again. Yeah, if I look at the parameter, then I have a time selector, right? Because I said it was a timestamp, right? So then I can, choose a date and time and that sort of stuff, right? AM and, this kind of clock, stuff like this, it's just a date selector. Now the date selector, I can do UTC or local, and that's important because every timestamp in Velociraptor is in UTC. It's always showing in UTC. So it has a Z at the end. But sometimes it's easier to, work with local. So you can switch between one or the other here. And what that does is it creates a timestamp in the VQL. Is there a list of VQL parameter types somewhere? Great question. Next slide. So yeah, there. Right. So over here, so this is the different parameter types that you can have. But usually, like if you don't specify anything, it's a string by default. I think you can also say string, but it's the default, so it doesn't matter. But you can specify an integer or an int. Then you can specify a timestamp, as I've just shown, and a CSV and JSON. We're going to talk about those why they're useful later, but it's basically a CSV formatted list of rows, like a table, basically. And then JSON, and then finally a bool. So when you have a bool, then you have like a checkbox, true, false. We've seen that one before. Another question: if you would like to have a column for process info command line, would Velociraptor run the query multiple times? No, it doesn't. So basically, what you do is a very good question. This is not so. This is a good question because a lot of the time we want to export this data to another system. And a lot of systems, they need to have a flat structure, right? So this kind of structure where you have like a nesting, it's not very convenient for many systems because especially if you're going to put it in something like an SQL database, then it needs to be flat. So you need to have all of these columns as separate columns. And so what ends up happening in these kind of things is that you need to kind of like, tease out these things, right? So what you need to do in order to do that is create a stored query. So you make a stored query like this, let x equals that. And remember that stored queries are lazy, right? So they only run when they need to, and they run immediately, right? So, and then you can essentially select from that. But what we're going to do, so, for example, here as, I don't know, socket, whatever. And then you can just select these things. And then when you come to this field, right, then it will be process info. Now we're going to go deeper, right? .exe, that's this one, comma, process info dot, and then version information has to be together. Dot, let's say company name. So you are going into the data structure, and then that kind of flattens it out. So you have to like do this flattening thing, and so on like that, right? And then from, obviously from X. Oops. So that is basically free, right? So essentially what we'll do is it runs that query chains to that. And because it's a stored query, it just runs it. So essentially, remember how I mentioned yesterday that what you need to do is visualize how the rows work, right? How the rows are passing through the query. And the way that rows are passing is a row comes out of this, it gets filtered, it goes into here, and then it gets passed into there, and that row comes out, and then it comes out to X, and then it comes into here and it goes to there, right? So it actually, that's how it's going to work. It's asynchronous, so it actually does it all at the same time, but it's very cheap, right? It doesn't take any more time, and you know, you can do it as like that, right? So that breaks it down into a more flatter structure, you know, so like this kind of, right? So that's very common to do these kind of flattenings. Cool. Okay, how are we doing for time? Okay, cool. So we are okay. All right, so we can create an artifact from that, right? We've talked about that. We did the WMI subprocess artifact, and we talked about how we can change the constants that we use in the query. We can change that to a parameter that makes the artifact much more useful. And then we can create a hunt, and we did that. And hunt for it everywhere and find, you know, our malicious hosts and detection. Okay, so I've got a couple of slides here about artifact writing tips. So you can do this, let x equals and stored queries. And that helps a little bit because those are essentially like commenting it out, because it doesn't really do anything with those. If you recall, that stored query doesn't run anything. So usually when you work in the notebook, you can create multiple queries. And I think I showed that yesterday when I created the PS list query, and then I created the stat query as two separate tables, and, you know, just kind of copy pasted some values from one to the other just to kind of understand what's how they're supposed to go together. So it's like an intermediate, you know, practice. The other thing is use the log function. So this is a really valuable piece of advice here. When you're writing your artifacts, it's difficult sometimes to know what. Let me just create another thing. In order to debug what's going on, then it's better to use the log function. So here's an example of a very simple query. So here we've got PS list, right? So, you know, we'll start simple, limit 50, let's say. So you can see that it's giving us a whole bunch of data here. And let's say that I had a query that said something like, you know, where, I don't know, username matches Mike, right? And, you know, or let's say, you know, I misspelled that, right? So it returns no rows, right? Because it's misspelled. But if I didn't realize it, and I'm like, okay, I don't understand why it's not returning any rows, what you can actually do is you can actually print a lot of the information in a log message. And we're using the same technique that we used yesterday, remember, with our log exercise. So you can use this log message equals, right, username. And if we do that, right, then what will happen is, remember, the log function always returns true, and then it will also print the name of the message, right? And then the message is going to be the username. So when we run this, it will actually print all the usernames as it's evaluating them row by row, right? And it's just like debugging. It's just like printing it. But you can see that it's printing it even though the column is eliminated, right? But we just don't know why it's eliminated, right? And so we can actually, you can use format to write like a format string. To write this, it's like a print debug, right? And then you can, you know, write like username, comma, I think it's Sid, I'm not sure. And, you know, oh, it's not Sid, it's anyway, I don't know, name, whatever. And then you can see you can see that. So it's as it's evaluating each row, then it will print it, and you can see how it's going as it's going along. And even though your query is filtering these things out, so it's just a really good way of debugging the query as it goes along. The other thing is the other trick is using in this format, using this %T, and the %T is actually tells you the type of the item. So in this case, we can use %T, and it will just say it's a string, right? So if you're not sure what the type is, then you use %T to tell you. So a timestamp epoch is time.time, right? So this is the type of the item. So a lot of the time you end up with like time.time, for create time and so on, right? The other thing is that you can also call other artifacts from inside VQL. And this is really important because we can use that to build a more modular set of artifacts. So here's an example. There is an artifact that collects, that just lists all the system users. You can see it in here. If we look at it here, search for users, and down here. It's actually a pretty complicated artifact. It has it's not complicated, but it has a lot of functionality, because it actually, if you look at it, it looks for local users by looking at the registry as well. And then it also has the users plugin, which uses the enum users API. And we're also reading registry keys and so on. So we're actually looking at evidence in the registry that the user logged on. Like, for example, a network user with an interactive logon will create registry keys. So we're looking for those, as well as finding local SAM accounts and accounts from the SAM and other things. So so this is actually a lot of functionality. But a lot of the time, listing users is kind of a common thing to do, right? You want to do that fairly frequently. Well, it turns out that you don't have to reinvent the wheel. You can just call that artifact from within VQL. And the way that you do that is when you want to call another artifact, you have to use this artifact keyword, this artifact. It's actually a plugin. So it's a plugin that launches artifacts as part of itself. So it's capital A. Not all the other plugins are, small case, but this one is special. And the way that you call the other artifact is using this dot. So you go dot, and then you can see that it's telling you the next name of the artifact. So we're going to do Windows, and then you do a dot, and then so it's basically building up the name, right? System dot users. So it completes the artifact names for you. But when you run that, then it's just the same as running the actual artifact, as you can see. And so it's just telling us all the list of users, like Mike, SSH, and so on. But the cool thing about it is that it looks to us like this artifact is like it's just another plugin, right? So it looks like a plugin. So I can filter it. So I can go, where name matches Mike. Right, and so that will filter only that, and so it will show me the seed and m time when the user was last logged on, and the type of user and these kind of things, right? So but this is true for every artifact. So even the custom ones that we've just written, same thing, right? Except that what we would need to do is start with custom, because their name starts with custom. And we had our WMI artifact, parent process. Great, let's see. So this is the one we created today. So we run it, and the same thing happens, right? So it just runs the artifact from another artifact. We can call one artifact using another artifact, right? So if you go into the artifact, so this is the artifact we created before, and if we put a question mark in there, if you recall the parameters that we added to the artifact in the definition, when we call it like this, those parameters are like arguments to the artifact, right? So just arguments. So we can use a process regex here. We can change it. Remember how it was cmd.exe? We can do like PowerShell, right? Or whatever, like search for PowerShell. And I mean, we can do it here. Actually start a PowerShell script and you will be able to see PowerShell. Okay, so we're starting PowerShell. So we go over here, do a refresh, and we'll see that. So you can see that the parameters then become like parameters that you can call. So it's like when we're writing an artifact, we're actually writing a little function, a little module that we can call, and build on that. So you can build on that. You can write artifacts that use other artifacts and modularize it like that. Okay, cool. So that is actually pretty useful. There's a couple of slides here about times. So when we have times, we have strong types. We talked about the %t trick before. And then timestamps are given as time.time types. So you can actually do some fancy stuff with it. Like you can call, this is the link to the Golang. So it's a Go type, time.type. So all of these functions are available in VQL as well. So, things like, getting the minutes, the seconds, these kind of things, right? So you can do these kind of formatting. I think we have an example here of formatting. I think it's the next one. Yeah, format the time in a particular way. So you can actually use you can do it like this, right? Because the timestamp has a day, a month, a year, hour, minute, second methods. So you can call them and format it. So yeah, so times are useful. So you can convert from strings to times and then back again. There is a timestamp function that takes an epoch time, or it also can take a Microsoft Win file time or a string time or whatever. So it converts into times from all kinds of types. We have a question. Can you hunt the embedded executable file that's injected to the legit file, like in Office files? So it depends what you mean. So we can do things like OLE. There is an OLE parser that you can use to unpack, the OLE VBA type stuff. We can unpack things like zip files and so on. So, but yeah, I mean, I'm not sure that we can. It depends really on what kind of embedded file it is. Okay, cool. So, but we can usually like do a Yarasig, and then if we find it, we can fetch that file for post-processing. So we don't want to try and have like a fully powerful malware analysis on the endpoint. It's just enough to be able to triage the file and then bring it, and then we can do proper malware analysis, in a sandbox and these kind of things, right? So there are parsers for VBA and zip files and things like that, but we don't want to go over the top in that too much. Well, at least, I mean, you can extend it. All right. There's a few notes here about temp files. I'm not going to talk too much about it, but you can create a temp file. And when you create a temp file, then when the query ends, then it will delete the temp file, so it won't leave them behind. So you can use that to create temporary files so that you can during the query execution, and then it will clean up after itself. But yeah, so let's just quickly go on to the control structure. we talked about for each before, and I said it's like the most useful kind of of plugin. And we talked about having the two parameters. There's the row parameter where you put a query there, and the query parameter. And then for each row that is emitted from this parameter, then we run this second parameter. It turns out that you can also use row, instead of having a query here, you can put anything that's iterable. So like a list or an array or something like that. And so that's also useful. And then you can still run the query on it. And if you just have a list here, then this query basically gets this special value underscore value because there's no actual columns. Okay, cool. Then there is an if. If is quite useful, and we use it a lot. If is like an if statement. Basically, we have a parameter called condition, and this condition can be, a query, or it can be something that's, not a query, and and we can basically run different kinds of queries based on that. So, here, any of the enrichment, I don't know, like there's an enrichment one, and you can see you'll be able to see us using if a lot of in a lot of examples. Yeah, I don't know about specifically. There's got to be an if somewhere. Find it. The file finder actually uses. Yeah, so we've got an if here. See, so if we selected the hour rule, then we run this query that uses the hour rule, right? Otherwise, there's an else. If there's an else, we run this other query. And this is using stored queries, so it doesn't have to nest them too much. So, so if is a very useful plugin that we use it all the time for control, for conditional control. A switch is very similar. And then a switch basically has a bunch of queries, and then the first query that returns results, then it stops after that. So because VQL, by the way, VQL uses keyword arguments for all the parameters, so you can't really have positional arguments. They're all keyword arguments. So it's sort of like taking inspiration from Python there. But Python allows positional arguments, but VQL has gone even a step more than that. So for things that kind of need to have some kind of order, then you just put any name in here. It doesn't matter. It basically uses them as positional arguments for now. So A, B, C, that's good enough, right? Chain is similar to a switch, except that it does all of these queries together. It just chains them. So it does the first query, then it does the second query, then it does the third query, and all of the rows from these ones, they all come out into the same thing. All right. So the last thing that I wanted to cover here is aggregate functions. Aggregate functions are actually pretty. Let me just, before I do that, let me just check. Question: if I would like to have a column for process, oh yeah, we've done that. Can if be triggered from specific parameter chosen? Yeah, of course, right? I mean, this is what you're seeing here. There is a you can see there is a condition. If the condition is true, then you can, if someone provided this parameter, more recent then it will be true. Then we do this, right? So it doesn't matter what this condition is. It can be anything, as long as it evaluates to true. Then we use it. So if you use a bool parameter here, for example, so even here, upload file. You see here we have a condition, upload file, and not is there. So if it's not a directory, and the user selected upload file, then we upload it, right? So that's that. There's two versions of the if plugin of if. One is a plugin, and one is a function. So the plugin version, remember the difference between a plugin and a function is a plugin returns lots of rows, and a function returns just the one, just takes one value and returns one value. So okay, cool. So let's get to aggregate functions. So aggregate functions are basically functions that have state. So that means that normally when we run a VQL function, it doesn't really have any state. So it operates on each row in turn. So for example, if I did something like, I don't know, PS list, again, we'll do this example here. I can do something like format. Right? Format is a function. It's just a normal function, right? You know, which I can use something like this, args, and then provide two arguments, maybe the name and, you know, the PID. So this is an example of a function that, you know, it just creates a kind of a format, right? So it gives it two parameters and it runs this thing. But the way it works is that every row, so this PS list again returns rows, it generates rows, and each row comes out of there and it goes, you know, again, the life of a query thing, right? It goes into this, and then this evaluates this row and then the next row and the next row. But format doesn't really have state between each call, right? Each call is separate. So we are calling format multiple times and it doesn't really have an internal state. So it's not an aggregate function. But there are a bunch of other functions that have internal state, and they're called aggregate functions, because we use aggregate functions to aggregate or collect information across different multiple rows. So the best example for that is count. So count is a function that counts. In order to count, you have to keep state, right? Because you have to remember what was the number, you know, last time. So when you run this count function, every time you evaluate it, it remembers the number for next time. So it essentially has its internal state. So when you run it like this, then you can see that the first time that you run it, it's 1, and then the next time is 2 and 3 and 4 and so on. So that that state is kept inside the function, right? So that the function is keeping state. When the row is evaluated, then it returns. Now we might say where, you know, if I do a where name matches CMD, right? So that's going to filter out most of these rows, and the count starts with 1 and 2, right? And when we understand why that is, right? Again, because this is lazy, right? So the same thing that happened in the first, you know, last session, we talked about lazy evaluation. And because this is still lazy, because VQL is still very lazy, right? So when we are filtering things out, then that count function is not evaluated. It's only ever evaluated when the row is, you know, actually emitted, right? When the row is calculated, then we calculate the count. And the side effect of calculating is that we add 1, right, each time. So this is why here we're going to count 1, 2, 3, but only from the ones that are matching, right? We can do the other way as well if we wanted to, where count and, right? So again, okay, so we can do it either way, right? But this is again, again, it's to do with the lazy evaluation that we talked about yesterday, right? So you can do either thing. But anyway, the point is, getting a little bit off track. What I wanted to actually say is just that this count has state, right? So each time you are running it, it has state. So so there's a whole bunch of aggregate functions. There's count, there's sum, there's enumerate, and there's rate. So there's a couple of ones, and we're probably going to add more, in future. But let's understand how that works. Aggregate functions are often used. They don't always have to be used, but they're often used for post-processing and especially to do stacking. So I'm just going to show you that here. So I think we had a hunt here that we did yesterday, right? So did we do it? No, we didn't do it. Oh, we'll do a hunt real quick. What were we hunting for? Task scheduler. Okay, cool. So, actually, this was the hunt from yesterday. No, it was not. That's right. The hunt that we did in session 1. I'm going to talk about that here. So if you recall, in session 1, we did the hunt across 2,000 machines to find scheduled tasks, right? So back then, I'm just going to switch to that other server right now. So we had 2,000 machines. We collected all our scheduled tasks. And if you recall, we already kind of had a bit of a taste. And remember, I said to you in the first one that we're going to have a little bit of a taste as to how we're doing these post-processing across our machines. So we did a hunt and we got our results. And what we're doing here now, we can look more carefully at how these VQL looks like. So again, we have a VQL plugin called Hunt Results. What that plugin does is it looks at the hunt. So it's a server-side plugin again, and all it can do is look at the results that are collected. They've already been collected from the hunt. So it just kind of like literally opens files, on disk, and then it emits each row into the query, right? So that row comes out. So we give it the hunt ID and the artifact that we want to look at. So this is the task scheduler one, and then essentially every single task, it's going to, from each host, from all the hosts, is going to emit them as a row. So it comes out 1, 2, 3, 4, etc. And then in this example, what we're going to do is add a count function to the columns. So we'll probably also want to do a fully qualified FQTN. You'll see that every client has its FQ. I think it's like this. There's a client name. That's the client name, and because it's a hunt, right? So it has results from all the clients. So we need to know which client has what data in it, right? So we don't want to see all the columns. We just want to see these ones right now. But you can see that essentially every time this count is evaluated, that number goes up 1, 2, 3, 4. So this is the aggregate function, but there's going to be literally hundreds of thousands of rows in this hunt. It's a big hunt, 2,000 machines, right? So what we really want to do is we want to only look at maybe certain files, right? So let's start to filter. So in this case, we're going to look at all the commands that possibly match cmd.exe, because this is a task scheduler, right? So a lot of the time, malware wants to add persistence for a task scheduler, and they might run some PowerShell or command prompt or some batch files or whatever to install themselves. So for this example, we're going to assume that we've got cmd.exe. Off we go, and we are only going to look at 50 for now. So you can see immediately we are filtering out, these rows, right? So filtering them out. So again, there's nothing really magical here because the count is just going up by 1 for each one. But that's because the function count has its internal state, right? But the magic really happens when we group by. So I'm going to just do this group by. And group by, what does group by do? What we're telling group by is we're telling it to do a combination. So in this case, we're going to look at command and arguments together. Right? So the combination of command and arguments. So this is an expression, right? it's going to take both of those columns, it's going to put them together. And for each of those, when they're unique, the unique value, it's going to make a group out of it, because that's what group by does. It makes groups. And what does that mean when you make a group? So when you make a group, you take all the rows that have the same values for these, right, for this expression, and you put them together in one group. And the way that it works is that this group basically creates a state for aggregate functions. So all the aggregate functions are going to use the same state in that group, but in the other group, they're using a different state. Does that make sense? So if we are running this, what does it actually do is it does exactly what you expect that it would do. It basically just counts all the items that are the same. But the way that it works is, I'll just let that run because I have a slightly smaller example in the slides. I have a picture here to explain what does group by exactly do. So this is the example here that I've got, right? So what group by does is if you have a table, right? So let's say X and Y, and you say group by X, right? So what it means is it takes all the columns, all the rows that have X the same, right? So this one has X the same, and this one has X the same, and it puts it into a bin. So all of these, they go into one bin, right? And then all the other ones, they go into the other bin. So we end up with essentially bins. This bin has these rows in it, and this bin has that row in it. So it's like a big group. So this is the group, right? And then the count, the count is it basically looks at all the rows, in that bin. But the way that it works is that the aggregate function has its own state, but the state is per bin, right? So this is one state and that is one state. So that's why it works, right? So when we count, then you see that it ends up that this is a group. It's this one row is a group, because that's what group by does. So that's one group, and then that is another group, and then the state of all the aggregate functions in that group is, there's one state. So whenever we evaluate count inside of this group, then it adds the count to that group only, right? Not to the other groups. And that's kind of how it works. I'll show you another example that will make it much, much clearer. But essentially, it does what we want to do in terms of stacking, right? To find the unique groups and count how many items are in each group. But it works by this, enumeration, right? So let's have a look at another example, and this is a very useful tool when you want to count all the rows just as just a big count, right? And you don't really want to create the groups. You don't, like in that case. You can always do a group by 1 or any other constant, really, it doesn't matter. Because what actually happens is that this expression evaluates to the same value all the time. So it ends up just creating one bin, right? And then it just counts all the items in that bin. So for example, if you wanted to know all the, what was it? Let's go back to here. If we wanted to know how many processes all up, then we can just do a, so here we could just do like group by commands, group by name, and that would show us a count of how many instances, for each process, right? So then we can do order by count ascending, right? And that will show us, oh, we've got SVC hosts, 70 of those, right? So we can do this counting per group. But if we just want to know how many processes all up, then if we just do a group by 1, then it just tells us all the processes, right? 150 straight up, right? Because it creates one group of all the processes. So that is actually a useful tool that we actually use that in a number of queries. And finally, I have this example here. I'll just show you this example uses a number of different. Can you order by alphabetically? Yeah, I mean we just did that order by. Yeah, we order by account or whatever, or name or whatever. Yeah, so order by is sorts it, right? Yeah, so I have an example here. So what we have here is a CSV file essentially. We have an X and a Y header, and then we have just some numbers here. And what I'm showing you here is I'm just parsing that CSV file so that just to get some data to work with. And I'm showing you some of the common enumeration aggregate functions. So count we've seen. Enumerate is basically it aggregates all the aggregates, all the rows in the group. It just copies them into a big list, right? So you end up with like a big list. So for example, you see that in this case, we're grouping by X. So we're going to have one group that has this, that's the one, all the ones, they go in this group, right? The 2 goes in this group. There's going to be 2 of those. And there's a 5, right? So 1 contains 2 rows, 2 items, and these are them. So enumerate just kind of collects them together, and sum adds them up, right? So, and then this guy, 2, there's 2 rows in here, right? And it comes here. Now, it's actually important to realize that the value of Y here is kind of random. Don't rely on it. When you're doing a group by, it sort of doesn't make any sense to collect other columns that are not part of the group, because what happens is, I mean, essentially the value that will end up taking the Y value is the last row that goes into the group, right? So, and that's kind of a random number, a random value. It's one of the random rows that ends up going into the group. So it's not very reliable, and you can't really use it. It's not useful, right? So it's not a good practice to rely on a column in a group by that is not part of the group, right? But I mean, that's the same in SQL. It's the same problem. Okay, cool. So yeah, so that's the group by. I have a whole bunch of stuff here about events. I was hoping to, can you filter the Y column? Yeah, so you can. Yeah, you can filter by the Y column in this case, if that's what you wanted. And then the filter will apply first, and then the group by, and then the order by. Yeah, cool. So I did wanted to cover some of the event queries, but maybe we have like 5 minutes. Yeah, let's do it. This one is a very quick exercise. Only takes about 5 minutes. So I'm just going to really introduce event queries because they are it's because this is a VQL thing, but we're going to do them a bit later on in more details. So basically, we talked about VQL, and we said VQL was asynchronous. So it basically, you don't have to wait for the whole result set to come back. Essentially, as soon as data is available, it becomes available, right? So remember, we talked about visualizing how the rows move through the query. We talked about the life of a query. You can see the rows going, through the query, right? So so then it occurred to me, like, okay, what if we had a plugin that never terminated? So if the plugin doesn't terminate, it just continues to send rows to the query, right? And as soon as the rows are sent, they're going to go through the query and get processed. But essentially, we're going to go back and listening to, watch for new rows to appear as well. And when you think about it, that creates something called an event queries. So if, for example, a plugin will release a row for each event, then it's basically becomes a way of monitoring or creating a monitoring type setup. So let's have a look at how that works in reality. So we have a VQL plugin over here, and let's say that plugin, it just it's like it just waits, right? It doesn't do anything. It just sits there and waiting, looking for an event of some sort. An event will going to happen, and then whenever an event occurs, a row is released into the query. So it goes into the query, and then the query can filter it, can have a where clause or whatever, and then it batches those rows a little bit, and then it sends them to the server a little bit. So in a partial result set, so it sends small result set along the way. So here's an exercise. We're going to do that real quick. Okay, so we're going to do this very simple, right? Select star from clock. So, not that one, clock. So clock is a very simple plugin, and it's the simplest event plugin. So if we can just run that, and you'll see that what happens is when I run it, it looks like it's very slow, right? It looks like it's taking some time, and it's releasing, it's still running, and it's going to release 9 rows in 9 seconds and so on, right? So basically what happens is it's releasing rows and it doesn't stop, and it will never actually stop, right? We can press stop to stop it. But what happens is that if you look at the columns that come back, these are all the columns of the time format. Remember I mentioned before the time.time, we have the timestamp. And this essentially every second, this clock plugin is returning 1 row. And you can see that this thing is just kind of, it's running in the UI. It's just waiting for this to happen. So it's actually no different than if the plugin was just extremely slow and it just took forever to actually do anything. And it released rows as it went along, and we're getting partial result sets as it goes along, right? So essentially that is what an event query is. And it's very simple to see, right? If we select Unix, we'll get a timestamp. So this is just one of the columns, which just gives us a Unix timestamp, right? And we will see, the same kind of thing happening, right? Every few seconds, it will, every second it releases 1 row. So 51, 52, 53, 54, right? So that is an event query, right? Now we can build an entire monitoring architecture around this concept, because those event queries can run indefinitely. Is a question, can we calculate the performance of the command consumption against machine resource? Yes. So as you can see, I think I've covered it the other day in the first thing, is that we're always collecting telemetry from the endpoint. So so we know how much CPU load that we're using as an aggregate. So we can't, of course, break it down to a query, but we know the process, right? Like how much memory and CPU usage the process is using all up. So we do keep monitoring that. So when you run a query, then you should be able to see, some impact on it or whatever, right? But it's usually not very big, right? So, is there a way to limit it? Yes. So we can do these resource limits. We're going to talk about them later. Essentially, when you do a collection, you can control the any of those. There's a specify resources here, and you can control how fast they run it on the endpoints, how long for, and these kind of things. When can we get the video from yesterday? Hopefully we can get this later on, maybe tomorrow. We have to edit it still. Cool. Okay. So client monitoring architecture. Yeah, so basically inside the client, we have a whole bunch of event queries that run in parallel. And when any of those produce rows, the client streams them to the server, right? So here's the client. It's going to run here. And here we have these event queries. So there's just VQL queries like anything else. And then they just run along. And they actually can even run when the client is offline. There is a local client buffer file. And then we take that file. In that file, we queue up all the messages. So even when we're offline, the messages are getting queued here. And when we come back online, then we just stream it off to the server, right? So these are the results. So here's an example. I'm just going to show you real quick an example of how that works. So the UI for it is down here, client events. That is the UI for managing and viewing event queries on the clients. And the way it works is that if I press the binoculars, I will be able to see the current monitoring table. So that's the current event queries that are configured for each client right now. So you can see that it's broken by, so it's just artifacts. So again, artifacts are just a way of wrapping or encapsulating the VQL query. So I'm just going to add another one here. And with client monitoring, we can target groups based on labels. So I'm just going to choose the all label. And this is an example of one that I did before. But anyway, I'll add another one now. So one that I like to use is a DNS one as well. DNS. Oh no, that's the server. I want the client. This one is for the client. So this is a DNS monitoring type artifact. Sorry, the ETW one is better. What it does is it uses the event tracing for Windows to essentially intercept all the DNS calls from the endpoint and report on them. So all I have to do is just select it. I can configure this so that it's the same thing. It looks the same. The UI is very similar to the client, to the normal collection UI, except that what I'm doing here is I'm adding those artifacts to the event table. So they're actually, so once I add them to the event table, they're going to be synced to all the clients, and all the clients will start to run those queries permanently and, and monitor for those, for those events. So when I do that, the client will sync it, and sorry, I've added the ETW DNS. Now it's going to take some minutes for this to kind of get cached, to get batched, because the events are happening, all the time, and they'll just get batched. So I'm just going to generate some DNS traffic here. I don't know, like YouTube, maybe. I don't know. We'll just generate some DNS stuff. Just normal browsing activity, and the client is actually collecting this information right now. What if the client did not receive the collection query? Well, then it wouldn't be updated, right? But so the way it works is that obviously they're always connected, so it will always work. If it's not connected or it's not online right now, then when it comes back and checks again, then it will realize that its event table is out of sync with the server, and it will refresh and it will resync itself, right? So there is like a versioning type thing. You can see the logs. So the logs show us essentially when the query started on the endpoint. So the logs are telling us that the query is running on the endpoint, and it also gives us like a bit of a heartbeat every 5 minutes. But eventually, I think it takes a couple of minutes, because we try and batch it. I mean, we get the event immediately, but we actually try and batch it so it doesn't, so we don't, send too frequently messages, right? So we'll come back to that in a couple of minutes. We should have something there. Now over here we have another example here. This one looks at this is a query that I was working on. I will probably do that as a quiz a bit later on. But it detects hashes in the downloads directory when they appear. Quick question: what if the client? Oh yeah, no, we've done that. Okay. Cool. So anyway, I'll just we'll come back to that. Oh yeah, here we go. So now we've got some DNS stuff, right? Here we go. So you can see that the DNS queries that we are monitoring started to come in, and this just happens like totally automatically. You don't really have to kind of worry about it or think about it. It just feeds the DNS back to the server. So that's event queries. We're going to do a lot of interesting stuff with event queries. This particular event query in the slides, it's watching the event log for events. And it's an event query, which will basically, as soon as the event appears on the event log, then it will generate an event and respond to it. Can you select two froms at the same time? What does that mean, to select two froms at the same time? I guess, whoops. I guess you meant like a join or something like that. Then we can use the for each plugin to do that. Otherwise, you can do a chain, which you can select one query from something and then the other query from something, and then you get the two sets of rows combined in one table. Cool. All right. So let me just quickly go through the conclusions. Okay. So this module was over 2 sessions because it's quite a large one, and we looked at VQL and a lot of details, and some of it was quite technical, but you saw that it was actually really important, and it comes out quite often. These kind of subtlety. But I guess the best thing for you guys is to just try and visualize how the rows flow through the query. We learned about stored queries, and we learned about being lazy and the control structures. So basically now, armed with this knowledge of VQL, in the next module, we're going to be able to use that to write more forensic detections, and actually we're going to learn about how to employ that, and we're going to look at some of the forensic capabilities in Velociraptor. And again, VQL just kind of like puts those together in an unusual way. But now we can be more proactive. Okay, one question: if I create multiple client event artifacts using the same watch plugin, will they share the same pipe trace? That's an excellent point. Yes. Generally, yes, that's true. So if you are watching, for example, a particular event source, like the event log, then all of the queries will actually receive the same events, right? But this is kind of an optimization in the binary in Velociraptor so we don't have to parse the same thing multiple times. So yes, it's done efficiently to try and share that together. Okay, another question: will DOH or TLS 1.3 affect the results of the DNS artifact if enabled in the browser? It's a good question. I don't think so, because the DNS artifact is using the event tracing for Windows. So it's actually designed for this very purpose, right? So again, I must say that the software has to obviously support that. So if you're using something like Edge or something like a Microsoft product, then it would be generating those ETW events, because that's kind of what it's supposed to do. Of course, if you're using custom software that does its own DNS lookups, that doesn't use the system DNS, then it's entirely possible that you won't see that with ETW, of course. But yeah, generally speaking, like, the difference, there's another ETW source for parsing URLs. And to give you an example, an Edge, even the new Microsoft Edge does generate those URLs in the ETW, so we can listen to all the URLs as they are being used if the user is using Edge. But if they're using Chrome, then we can't see that because they don't generate those events. So Microsoft tends to always, generate the ETW events, but that's not necessarily always the case. will we be able to parse AM cache and shim cache? Yeah, I mean, we're going to look at that in the forensic artifacts. So in another 2 sessions, session 2. Cool. Okay. Great. So that's it for today. So hopefully we'll have the recording up soon, or maybe in a few hours. And what I'll do is I'm going to try and get also the recording for yesterday and add it to the video links over here. Cool. And I'll see you guys tomorrow, same time. Just going to stop the recording. Stop.